Okay, now we're recording. All right, so we're doing the little bit of 5-1 that we have left, and then all of 5-2. And again, we all have our our identities out because we're going to use those. Your class Alpha, we already did this one problem where we had to factor down 4 cosine squared x minus 4 cos x plus 1. I did this with A yesterday, and G period hasn't done this problem yet. But I'm just gonna reminder walk through it because I think like 99% sure that there's a problem like this on your homework. So I would kind of look back to this when you're doing your homework. Remember that instead of thinking about it as 4 cosine squared minus 4 cosine plus 1, we put x's instead of cosine x's. And then we're like, oh, now we can factor this using our algebra skills from before. So it was kind of a weird factoring. It's kind of a tougher factoring, but we figured it out and we got 2x minus 1 times 2x minus 1. And then we can relate that back to the problem that was given to us. And instead of writing x's, we're writing cosines. So 2 cosine x minus 1, 2 cosine x minus 1, and then we set each like factor equal to 0, and then we solved from there. And then this problem was dealing with radians, so our answer was in radians. Everything else was in degrees. So just a reminder that we did do that one, and that one's like one on your homework. So I will answer questions like that on your homework next class, but I would go back to refer to this one. If you don't know how to do that problem, definitely come back here. All right, and the next two just ask for a calculator. These are pretty quick and simple. I'm actually going to get rid of our identities for right now so I can pull up our calculator. We've done this in some kind of capacity before. It says using a calculator, find all solutions of cosine x equals 0.37. Give answers in both degrees and radians. We're just going to do degrees for today. I don't really need it in radians for right now. You can always multiply by pi over 180 in order to get that. But when we're solving cosine of x equals 0.37, remember that we have to use our inverse. So anytime I do not have an angle or I want the angle, I have to think of this as inverse cosine of 0.37. And that's what I'm going to plug directly into my calculator. So second cos 0.37. Make sure that we're talking in degrees if you want your answer in degrees. So again, what I want and what the calculator's mode is should be the same. So I want degrees, we're in degrees. And so I get 68.28. So I'm gonna write that over here. X equals 68.28 degrees. Now we want to find one more answer. Remember that we are thinking about all the way from like 0 to 360. 68.28 is somewhere in this like first quadrant. So I like went up this way. If we remember our all students take calculus, that's going to tell me which one other quadrant would also have a positive 0.37 cosine. So all students take calculus. And so in the first and the third and the fourth quadrant is where cosine is positive. So I need to think about what would my cosine, what would my angle be if I was in the fourth quadrant as well. It has a reference angle of that 68.28, but now I'm in the fourth quadrant. So we're going to take 360 and we're going to minus 68.28 in order to figure out that angle right there. And so that's 291.72 degrees. And so those two angles are in our normal 0 to 360. Those would both give me a cosine of 0.37. Okay. Again, we've kind of done that before. The way that this question was worded was just a little bit different, but I try and keep relating what have we already done back to what we're doing right now. Is everybody okay with what I've done so far? Anybody questions? All right, same thing on the next one, but this one I want a tangent of x equals 5. So we're going to set it up the exact same way. Instead of pressing tan 5, we're going to press inverse tan or second tan of 5. And that's what x is going to equal. So second tan 5, ooh, too many tans. There we go. And that's 78.69. Okay, that being said, tangent is +5. So we have to think back to our all students take calculus again. All students take calculus. And I just drew, or we just found an angle that was 78.69. So that's in my first quadrant. And we know tangent is positive in the first quadrant. Tangent's also positive in the third quadrant though. So I know that in the first quadrant, my angle is 78.69. Now in the third quadrant, I'm going all the way to 180 and I'm going plus 78.69. So to find that second angle, we're going to do 180 plus 78.69. I have to go all the way to 180, and then I have to go an additional 78.69 in order to find the angle that matches it in the third quadrant. So I can just throw that in my calculator really quick. I'm going to get 258.69. And that is my answer. All right, that was just kind of different. We were just doing inverses in the calculator. We were doing inverses above, but we were having to solve them out and then set those equal to ratios that we knew from the unit circle. These were ones we didn't have on the unit circle. Nowhere on our unit circle did we have 5 or 0.37. So that's why, and because the directions told us, we used a calculator to figure that out. All right, anybody, any questions yet? Okay, this, I think 5 and 6 are like the least important parts of this 5.1 anyway. They might not even have homework questions that correspond with them, but I wanted to go over those really quick. And then now we're going to get into 5.2. And the cool thing about 5.2 is it builds on what we were doing in 5.1. So hopefully like we start kind of picking up on like little things that we were doing already. When we get here though, I would love if you guys want to help me out with this, because the more like you guys are involved, the better it's going to be. So I'm going to like kind of ask you a question. I want you to kind of like respond back. Because if I just keep telling you like where to find things, it's going to be like not really worth our time. So these all, there are 5 questions or 6 questions here, excuse me. And they say verify. What verify means is that I gave you a true statement. So this is a true statement. Ooh, this is a true statement. What I want to do is prove that it's true. I'm going to take one side. I'm going to take the side that's more complicated, and I want it to look like, get simplified all the way down to look like the side on the more simple side already. The side, in this case, that's on the right. So like with number 1, this side looks way more complicated than the side on the right. The left side looks way more intense. Like I can simplify that down. I want to get that all simple, and I know I'm done when I get sine x. So that's kind of like what my question is going to be, is like, how do we simplify the left side to get to the right side? Somebody in A period asked, so like the answer isn't really the answer, it's your work. It's like the journey to get there. It's you showing me all the steps that you did to show me that you have to get sine. Because technically I'm giving you the answer, you just have to show me how you get there. Okay. So I'll kind of walk through this first one, what I'm thinking. And then like, as we move on, I'm going to kind of like pause, and I really would love you to kind of help me answer these questions or walk through it with me. So this first one, I'm taking this left side and I want to simplify it. So I see sine squared x plus cosine squared x divided by cosecant x. What I first noticed, and what I told you guys yesterday, is anytime you see 2 trig functions squared being added together, or a trig function squared and 1 being added or subtracted together, I'm going to go look at these identities at the bottom. These are called Pythagorean identities. I don't know if I told Alpha, I don't know if I told your class that. I had forgotten what the word was, but somebody in G period helped me. So Pythagorean identities is what these are right here. And I see in the first Pythagorean identity, sine x or sine squared theta plus cosine squared theta equals 1. That matches what I have here. So I can replace sine squared plus cosine squared with 1. That whole numerator becomes 1, and I now just have 1 over cosecant. Now I see 1 over cosecant, and I go, okay, I'm sure I have that up here somewhere in my reciprocal functions. And I do, it's the very first one. It's my sine equals 1 over cosecant. Okay, perfect. So then this means that 1 over cosecant x is equal to sine x. And that is what I wanted my answer to be. So I did it. I like to put like a little smiley face. Ooh, that's a crappy smiley face. Try again. That's not great, but it's all right. Or like a check mark or something to show like, look, that's what my answer was and I got it. So we did it. First one's done. Anybody have any questions yet? Okay, we're gonna go to number 2. All right, now that first one I said, if you have anything like squared, any trig function squared, look at our Pythagorean identities. I don't have anything squared over here. So like my next trick is gonna be to write things in terms of sine and cosine. I think it's pretty obvious which side is more complicated. I would start with the tan x over secant x, and I would see if we can simplify that to sine. So my question now, I'm asking for crowd participation. What is tan x in terms of sine and cosine?
Sine over cosine.
Very good, sine over cosine. So I'm going to rewrite that numerator as sine over cosine. And what's secant in terms of sine and cosine?
Cosine.
Good, it goes with cosine. So I can think of secant as 1 over cosine. So I'm going to replace the denominator with 1 over cosine. Perfect. Now I have this big ugly fraction. So I put everything in terms of sine and cosine. Now I've got this ugly fraction. Let's simplify that. So I'm going to multiply by the reciprocal. So I've got sine x over cosine x times cosine x over 1. Now what?
Cosines cancel and it's just sine x over 1 or just sine x.
Perfect. Cosines cancel. I just have sine x over 1, which is just sine x. And that's what I wanted to get. I got my answer. Smiley face. We did it. Yay. Perfect. We got 2 down. We just have 4 more to go. Anybody have any questions yet? Okay. We're going to move on to the next one. So number 3 says cosine of x times tangent x plus sine x times cotangent x. And all of that should equal sine x plus cosine x. Excuse me, cosine squared. I believe the left side is the more complicated side again. And so we're going to get the left side to look like the right side. There's a couple different ways we could start. What's one thing we could do to just start moving on this?
Put it in terms of sine and cosine.
Good. Put it in terms of sine and cosine. So my cosine is fine as it is. So I'm going to keep it as cosine. My tangent becomes sine over cosine. We just did that last problem. My sine is already in terms of sine and cosine, so it's good. And then cotangent becomes cosine over sine. I can put the cosine and sine over 1 if that helps it make things a little bit easier. All right, what should I do next?
Cancel out the sine 1 and then the cosine sign.
We can cancel out those. We can cancel out these signs. So I'm left with cosine x over 1 times sine x over cosine plus cosine. So we canceled out those signs. I think you said 2 steps in 1, Curtis. I want to do that, cancel the cosines out, but let's call that distributing on this next step, okay? So we're going to distribute that in. Does that work for everybody? Now my cosines cancel out here, so I'm left with sine x. And then I have to do cosine times cosine, and cosine times cosine is cosine squared. And personally, I'm like, I don't really know what else to do right now. So I'm going to go check and see if I've reached my destination yet. Oh, and I have. We did it. We made it. Yay, go us. Cool. How are we feeling? Anybody any questions yet?
Is there like a first, like, is there one way to start problems like this, or is there multiple ways? Like, could you Like every time, should you put it in terms of cosine and sine, or is there other ways to start the problem?
That is a great question, Theo. The last two, putting in terms of sine and cosine, have been really helpful. What I said in A period yesterday is I said, like, if you're ever stuck or if you don't know what to do, just go put it in terms of sine and cosine. For this last one, we could have distributed first. We could have multiplied our cosine by both of those things and then gotten things in terms of sine and cosine. If you have those squares like here, this would not have helped us immediately to put cosecant in terms of sine and cosine, because we had the sine squared plus cosine squared. That was like an easier simplified down to make things look simpler, faster. So putting things in terms of sine and cosine isn't always your first step, but you often have to get there. Does that help answer your question?
Yeah.
The hard thing is there's no like one right first step. Like on this last one, we could have started it a couple different ways, but like you have to end up doing all the things. So you have to distribute at some point, you have to put in sine and cosine at some point, you'll have to cancel at some point. But the cool thing is that you could start one way, then a different way than I do, and often get to the same place.
Okay, thank you.
Yeah, of course. All right, if we're looking at number 4, I know we might be like differing on what side we think is more complicated, but I'm going to argue that tan x plus secant x is the more complicated side than the fraction side. So we're going to start on that side, simplifying that one down. All right, what should I do first?
Sine and cosine.
Sine and cosine. Awesome, Theo. And like this one, that's kind of our only option. There's not really anything else I can do. So tan is going to be sine x over cosine x plus, and then secant becomes 1 over cosine. All right, what next?
Would it be sine x over cosine squared x?
It would not be over cosine squared. So you're acting like we're going to multiply them together. I want to add them together. So if we add them together, does that change my denominator?
No.
Like if I did like 1 over 6 plus like 3 over 6, that my 6 would still stay on the bottom. It's just the tops that get added up. So we're going to keep 1 cosine on the bottom, and then we'll have sine x plus 1 on top. Okay, this is where I like to kind of check where I need to go. So, okay, I don't really know what to do next, but I'm not at my finish line yet. What I do see, and again, I kind of know this because I've done a lot of these, but I'm trying to give you guys an insight on what to look for. I see that I need to get 1 minus sine x on the denominator. So I need to get to a place where I've got 1 minus sine x in the denominator. I can't make anything right now be 1 minus sine x, but what I can do is I can multiply that on both top and bottom of my fraction, and that keeps like the integrity of my fraction. It keeps my fraction still equal to what it was. So I'm going to multiply by 1 minus sine x on both top and bottom. So you can always take something that you don't have, multiply it on top and bottom, and that still keeps the fraction equal, and it can get us more closer to where we want to be. Now, and again, I know this because I've done this more than you guys have. I am going to FOIL on top. I am going to multiply that all the way through to everything. I am not on the bottom. The reason I'm not on the bottom is because I want 1 minus sine x all by itself. So at some point, I'm going to have to get rid of that cosine. So if I just leave it like unfactored or undistributed through, I can eventually cancel them out pretty easily later on. Is everybody okay with that? Anybody questions yet? So my bottom is going to say cosine times 1 minus sine. And my numerator, I'm going to distribute. Technically, this is all in parentheses. So we do sine times 1, 1 times 1, negative sine times negative sine, and I get 1 minus sine x squared. Okay. Anybody questions yet? Okay. So now I go back and I zoomed out a little bit so I could see still what my destination was. Now I want a cosine on top. One thing my other class said was like, oh, well, let's just multiply by cosine on top. That is an option, but I think that a smarter option would be, okay, can I take 1 minus sine squared? I told you at that very first problem, anytime you see two trig functions being squared and added or subtracted together, or 1 and a trig function squared being added or subtracted together, I'm going to go look at my Pythagorean identities, because I'm going to argue that 1 minus sine squared is somewhere over here. And I see it right here. So cosine squared equals 1 minus sine squared. That means that I can take 1 minus sine squared out and I can put cosine squared in there. Anybody questions yet? Okay. Now that I'm here and I see where I want to go, what can I do now?
Could you cancel one of the cosines on top and then the bottom one goes away?
Yes, absolutely. I've got two cosines on top and I've got one on bottom. So I cancel out one of my cosines on top. So I just get cosine on top, and then the cosine in the denominator gets canceled. So I've got 1 minus sine x. And whoop, we made it. We're where we want to be. The hardest thing I think was the second step where I made us multiply by 1 minus sine x on top and bottom. We'll do another one or two like that. But if you get to a point that you're like, I don't have what I need and I don't really know where to go, look and see if you can multiply by something on top and bottom to get you closer to where you want to be. But we made it. Anybody? Oh, excuse me. Anybody, any questions? Any thoughts? Okay. All right, we're moving on to number 5. On number 5, I would say the left-hand side is the more complicated version. As again, I know they're both fractions, but since I've got a tan squared and a secant plus 1, I think it's going to be easier to get rid of that than it is the other way around. Okay, so I'm going to ask, what do we see first? Do we see anything I can replace or simplify?
Tan squared is the same as secant squared minus 1.
Awesome. And that's going to be helpful because I have just a secant plus 1 on the bottom, and I think that we're going to be able to use that. So I'm going to replace tan squared with secant squared minus 1 all over secant x plus 1. Now, this is kind of like the last problem, and I've showed this to you kind of going forwards, and this one is going backwards. Remember when we had that 1 minus sine x plus 1 and then 1 minus sine x, and we distribute that through to get 1 minus sine squared? We're going to factor secant squared x minus 1 very similarly. If we are confused by this, one thing you could do is think about, okay, what if it was x squared minus 1? We could factor that down, right? That's just a difference of squares. We know that's x plus 1, x minus 1. The only thing that's different here is that my secant is my x and that my 1 is my 1. So I can factor this down. I can go the opposite way that I just did last step, and I can make secant squared x minus 1 into secant x plus 1 and secant x minus 1 all over secant x plus 1. Anybody questions on that, the factoring down? Okay, we see that's helpful though, right? What can I do now?
Cancel.
Cancel. I've got a secant x on top and on bottom, secant x plus 1, excuse me. I have the secant x plus 1 on top and on bottom. So now I'm just left with secant x minus 1 Now we're getting close, but we're not quite where we need to be. What did I say we do whenever we're in doubt?
See if we can multiply by what's on the denominator.
We can. Let's see, can secant be written as a fraction though? What's secant the same thing as?
1 over cosine.
1 over cosine. So let's put secant in terms of sine and cosine. So 1 over cosine is what secant is. And now I have -1. Now, Theo, is what I want to do where we multiply by what's in the denominator. If on the first fraction, I already have 1 over cosine. For my 1, if I multiply by cosine on top and on bottom, A, that's going to let me combine those two fractions, and B, it's going to give me what I want in the denominator. So I've got 1 over cosine x minus cosine over cosine. And you actually can skip that step if you understand, like when you multiply by cosine, we're going to get like denominators, and you can go directly to 1 minus cosine all over cosine. And that is what I want my answer to be. We made it. I'll zoom out so you can kind of see all of it. But our first step was we took tan squared and we replaced it with secant squared x minus 1. We factored down that secant squared minus 1 to be secant x plus 1 and secant x minus 1, which let us cancel. What often happens is we get to this step and we're like, I don't really know what to do next. That's what I say, like when in doubt, put things in terms of sine and cosine. So when in doubt, put things in terms of sine and cosine. And when we put secant as 1 over cosine, it made it much easier to decide what was on top and what was on bottom, and that we could combine it to be our final answer. Yeah. Anybody questions? Okay. I got one more, and you see how much space that we have for this one. So this is one of the more complicated ones. And there's a couple different ways of doing it, but I think I'll show you the way that I think makes the most sense. Anybody questions before I get into number 7 or number 6? Okay. Also, I don't like t that much, so when I rewrite this, I'm going to start using x's. It doesn't matter what you use. You could use thetas, you could use z's, whatever variable you want, but t is just a variable, so I'm going to use t instead. I'm definitely going to take the left-hand side and simplify it to be the right-hand side, because it is two fractions being added together, so it's going to be easier to combine those and like break apart a fraction later on. Okay, whenever I have two fractions being added together, I'm going to see if I can get them to have common denominators so I can end up bringing them together into one big fraction. I also noticed that everything's already in terms of sine or cosine, so that's not a helpful first step because they're already there. I can't make anything in terms of sine and cosine because it's already in sine and cosine. What I can do though is I'm going to multiply the first fraction by sine on top and bottom to get like denominators. And I'm going to multiply the second fraction by 1 minus cosine to get like denominators. So I essentially took the denominator of the second fraction and multiplied it on top and bottom for the first one. And I took the first denominator and multiplied it by top and bottom of the second one. So just getting like denominators. I am not sure if I need to distribute in the denominator, so I'm not going to right now. I can always distribute later on, but if I have to unfactor it, that's going to be really confusing. So I'm just going to leave the denominator as sine x times 1 minus cosine x. I am, though, in this one step going to combine them all into one big fraction because I just got like denominators for this sole reason. And so I'm just going to combine them all together. I am going to distribute on top. So sine x times sine x is going to be sine squared x. And I am going to multiply 1 minus cosine x times 1 plus cosine x together. And when I get that, I'm going to get 1 minus cosine squared x. You can always physically distribute this 1 times 1, 1 times cos, cos times 1, cos times cos. But when you simplify it down, you're going to lose your middle term and you're just going to get 1 minus cosine squared. Okay. Everybody cool so far? No questions yet? Okay. Now, we often get to this point and then people see this. They're like, oh, I see sine squared x and I see cosine squared x. That equals 1. It does, but do you notice how the cosine squared has a negative in front of it? So that means it's sine squared x minus cosine squared x. And that's not what my identity says. My identity says sine squared plus cosine squared. So I am not allowed to cancel those out using my Pythagorean identity. I do notice this though, I do have 1 minus cosine squared, and that is one of our Pythagorean identities. It's one of the middle ones we haven't used yet. 1 minus cosine squared is the same thing as sine squared. So I can actually take 1 minus cosine squared out and get another sine squared in the numerator, which is going to actually be helpful to me. So I want my numerator to be sine squared x plus sine squared x. Anybody questions on that? Notice that I'm only allowed to do that when cosine is squared. So in the denominator, see how cosine is not squared? I can't replace that with sine squared or sine. It has to be exactly what I see here. I can't just make up squares or get rid of squares. It only works when there are squares there. All right, now, does anyone see anything I can do next?
Add the signs.
Add my signs, very good. So sine squared plus sine squared is gonna be 2 sine squared. I like to kind of check in, see where I'm supposed to be going. Okay. All right, what should I do next? Or what can I do next? One thing I'm probably going to do is cancel. I've got 2 signs on top and 1 sign on bottom. I am going to cancel that out. I know some of you might not have said that because I want a sign in my denominator, but I promise that like later on, I'm going to be able to get one back. So let's cancel my signs out so I don't have too many pieces here. So I can make that 2 sine on top over 1 minus cosine on bottom. We're going to want to sign on bottom, but what's more important, what's going to be harder to get is this 1 plus cosine. Anytime you have like 1 plus something, that's going to be much harder to find than just a single trig value. So just like we did on the last problem or two ago, I want to multiply by 1 plus cosine on top and bottom because I'm going to need him on top. I'm going to need him on top. So if we multiply him by top and bottom, then we're going to be able to at least have him on top and see if we can simplify down to get the bottom to be sine again. So again, if we're at a stopping point, go back and see which piece of the numerator denominator you still need. And especially we pick the one that looks like it's more difficult to get. So 1 plus cosine is more difficult to get. So we're going to multiply that. My answer is going to have 1 plus cosine in a parenthesis. So I'm not going to distribute on top because I want him all by himself eventually. So I'm going to keep my numerator as 2 times sine x times 1 plus cosine. Now my bottom is going to have to be sine at some point. So let's distribute my bottom and see if that kind of clears things up. So distribute, I'm going to get, oh yeah, the middle terms are going to cancel out again. Okay, we've done that a couple times. So I know 1 plus cosine times 1 minus cosine is 1 minus cosine squared. Now that I'm here, and now that I know that I want sine in my denominator, what can I do?
Turn 1 minus cosine squared x into sine squared x.
Perfect. We're going to take 1 minus cosine squared x, and we're going to make it sine squared x. We essentially did that already earlier in the problem. We're going to do it again. So I'm going to still have 2 times sine x times 1 plus cosine x in the numerator. Okay, let me pretend and try a little bit harder. 2 sine x, 1 plus cosine x. And again, we replace my 1 minus cosine squared in the denominator with just sine squared. All right, and so we need to get to 2 times 1 plus cosine all over sine. What's the last thing I need to do? It's the last thing I can do.
Take out the signs, like one sign on top.
I can take out the sign on top and I can get rid of the square, get rid of one of my signs on bottom. So that gives me 2 times 1 plus cosine x all over sine x. And again, I use x's instead of t's, but that's what I was supposed to get to. We did it. That was one of the longer ones that we've had to do so far. Oop, that's awkward. But I'll kind of walk back through exactly what we did. So the very first thing we did was got like denominators so that I was able to combine my 2 fractions into 1. So I combined my 2 fractions into 1. I saw 1 minus cosine squared, so I made that into sine squared. And I was able to add my 2 sine squareds together to get 2 sine squared. I could cancel out my sines. I then knew to multiply by 1 plus cosine because I knew I needed it in my numerator, so I had to get it there somewhere. So I multiplied it on top and bottom. I distributed in the denominator to get 1 minus cosine squared, so I could replace that with sine squared. I could cancel out my last signs, and then I got to my final answer. There is another way to do that, but I think that was like the most like intuitive way. Like we wanted like denominators. I think that makes the most sense to us. So I wanted to kind of keep it in that direction. Anybody have any questions? Okay, that is it for today. So what I want you to do for next class is to do the 5.1 and the 5.2 homework. We're going to go over those next class. We're going to do more of these practice problems. I've got one more day fully dedicated to 5.2. And then we're up for quiz next week. I believe your guys's alpha, yours is on Wednesday. A and alpha is on Wednesday. G is going to be on Friday because we've got that weird Thursday off. But we're going to have a quiz on this stuff, and then we'll keep moving into chapter 5. Anybody have any questions for me? All right, well, thanks for jumping on live, you guys, this morning, and everybody who's watching on YouTube. Thank you for getting caught up on your notes. If you have questions, I have office hours, and we'll talk in class on Monday. Have a great rest of your day.
Thank you, Miss White.
Bye. Thank you, Theo.